I'm Leah. I work in Google Cloud in the developer relations group. So what that means is that I'm a software engineer, but instead of building the end Google Cloud products, I build tools and other things that make it easier to use those products. So that could mean a tutorial or sample code or a blog post. Honestly, totally depends on the day. I specialize in Cloud Composer, which is GCP's hosted managed version of Apache Airflow. I've been involved in the Airflow community for a little bit more than a year now, and I've made a handful of commits to the project, but the majority of what I've done in the community has actually been non-code related. I've been to a bunch of meetups. I have helped organize the summit, which was really fun, and I got to meet a lot of people doing it. And I've also been indirectly contributing by helping other people figure out how to contribute to Airflow. And that's actually what I'm going to talk about today. So today, the story, it actually isn't about me. It's about someone else using Composer. And I really want to make sure I give credit where credit is due. The main character of today's story is my wonderful colleague, Emily. They did the vast majority of the technical work that's shown in this presentation. But because 2020 is 2020, extenuating circumstances prevented them from being here today. But they're a rock star and gave me permission to tell our story on behalf of them. So Emily, thank you for that. So before our story, we will have a prologue where I will make sure we all have the base knowledge we need to start the presentation. I will then talk about the BigQuery public datasets program. I'll talk about some of the growing pains that that program went through. I'll talk about what the goal of Emily's and my work was. We will jump into the DAG, share some lessons learned as part of our epilogue, and then there will be plenty of time for Q&A. So, as I said, before we start, I want to make sure we're all on the same page. I want to highlight the two key GCP products that are involved in my presentation today, Cloud Composer and BigQuery. As I said before, Composer is our hosted managed version of Apache Airflow. It's built on a bunch of other GCP products. The compute runs on Kubernetes engine, the web server runs on App Engine Flex, the database is in Cloud SQL, specifically with the MySQL database backend. And we use cloud monitoring and cloud logging so that users can collect their metrics and their logs, and they're readily available. Cloud storage is where DAGs, plugins, and some other stuff lives. And the identity-aware proxy secures the web server. We do run with the Celery executor. I know that's not a GCP product, but people are often curious. And not all of the underlying components are shown here. This diagram actually is from Rafael Villegas, who's the manager of the Composer team. And he gave an awesome presentation at the summit last week, specifically with a focus on security, where he does a bit of a deeper dive into those components. I highly recommend watching his recap. The second product I want to talk about is BigQuery. BigQuery is Google Cloud's highly scalable enterprise data warehouse solution. It's fully managed, it's serverless. You can get real-time insights from streaming data, built-in ML out of the box. Basically, it's designed to make data analysts and data scientists more productive, or at least make their lives a little bit easier, and to do so in a secure manner. One thing that's pretty cool about it under the hood is that storage and compute are decoupled, which means that they can scale independently on demand, which is awesome because it offers you compute and storage flexibility as well as cost control. And we know it's all about the money sometimes. And that's really different than traditional node-based cloud data warehouse solutions or on-premise stuff. Some things that I want to highlight that I really love about BigQuery are the fact that I can ingest data in batch or streaming form, the fact that I know there are pricing models that are per query and flat rate last I checked, and that there's a really great UI. I love a good CLI and a good SDK, which it also has, but sometimes you want to use a UI to do a deep dive and really visualize that data, and you can do that. All right, so now that we all have this background knowledge, we've got Composer, we have BigQuery, you hear those words, you know at least a little bit about what I'm talking about. I'm going to walk you through the story of Emily and I working together on Emily's very first Airflow DAG. I know sometimes we sit down to write code just for fun, but When we're at work, a lot of the time that the code we're writing is it's part of a bigger story. So before I dive deep into the contents of that DAG, I want to tell you about why we were writing it in the first place. And that reason is actually my favorite part of BigQuery, which is the public dataset program. My colleague Shane is a developer advocate for public datasets, for BigQuery public datasets specifically. And he introduced me to this concept recently. I love it. He calls it the data science method. So instead of being the scientific method, like you might have learned in science class in school, and if you didn't, I won't tell if you need to do a quick Wikipedia search, it's totally fine. So instead of that scientific method, it's the data science method, this generalized process that most data scientists use to figure out how to get like their data and then get to the insights portion of the program. So there's all of this, like you have to find the data, you have to figure out how to get access to it, you have to understand it, you have to get the data to where you're at. You need to update it, maintain it, you need to make sure the right people can access it, make it public or link it with whatever you have internally, and then actually do the analysis on it. So it's a lot, but this happens with pretty much every new data source you have to deal with. And I don't know about you, but I have also been pretty familiar with this 80-20 paradigm for data science, which is that a data scientist spends like 80% of their time accessing, cleaning and prepping the data, and only 20%, or like maybe less of that time, actually analyzing it and interpreting the results. I know for me personally, I used to work in a role where, in order to build our product, we had to utilize proprietary data from another part of the company. And I definitely felt that pain, the pain especially of the accessing the data. But we needed it in order to have these valuable insights. Sometimes it's unavoidable, but sometimes that kind of thing is not unavoidable. So how can we flip it? This is where the public data sets program comes in. If you could replace paid data with a free alternative that allows you to focus on the bottom half, the getting it and then getting to that analysis portion, you could be spending way more than 20% of your time just analyzing. And so this is where the public data sets come in. You don't have to find them. They're already in BigQuery and they're free and you can use them and they're awesome. So a quick overview of the public data sets themselves. In the current catalog, we have more than 150, if not more than 180 data sets that are ML ready. Some are structured and they're hosted in BigQuery. And we actually do have some unstructured data that's part of this program that is stored in cloud storage. I know one example of that is some satellite imagery. These are some of the data providers that we have. And we love that they are seeking our help amplifying the availability of their public data. And we're excited as more partners and providers come on board to bring their data sources and help make them available to folks, because it will only improve the use cases that are out there. I know personally, I use the public data sets this summer with my interns. They are working on a project that is using some of the data analytics and ML products at Google. And in their very first weeks, we had them go through the catalog. And we had a lot of fun picking out what we were going to use. And it was wonderful to not have to worry about what hoops we were going to jump through to get the data they needed to get their work done this summer. So the public data sets are awesome, no question about it. But the program has gone through some growing pains lately. I mentioned that it has like somewhere between 150, 180 data sets or more. But like anything else in this world, it didn't just start that big. Like many teams, it started from a small space with only a few data sets and a smaller team. And the program has had some growing pains as it's had to scale. So if you remember the steps of that data science method from a few slides ago, while my colleagues in the public datasets program don't have to follow it exactly, they're really just doing that accessing and loading and trying to get it into BigQuery part and not necessarily the analysis. They do still have two pain points that fall really well into the method. And that is the understanding the data set and how you can join it with what you have, and the loading it into their system. And as the program has grown, these two steps have slowed them down. As of late 2019, to onboard a new data set, the team had to do something like this. And the current solution, I do want to stress that it works. You should not at all be afraid of these public data sets. They're wonderful. But there's room for growth, and it could be a little bit easier on the team if we adjusted. So right now, how it works is the public data sets team, they get a data source, maybe from an external cloud or some external on-premise solution. It comes in and is stored in some internal temporary solution where the team has to manage who has access to that temporary solution. They perform any transformations that they may need to make it BigQueryable, and then it eventually ends up in BigQuery. And it works, clearly. There are a ton of data sets there, but there are some pitfalls. This data is coming from all over the place. And these organizations that are the data providers, it's not like they're talking to each other to say, hey, let's make sure our data is all formatted nicely so that it's all the same for Google to make their job easier. No, everyone has to make their data decisions about their organization. So the data is coming in different kinds of sources and different formats. When the data comes in, it's being stored in an internal resource as a staging thing. And I don't know if you've ever worked with a corporate proxy, but sometimes internal resources don't play very well with external resources like GCP or whatever your cloud provider is. That's really hard to have those talk to each other. Making sure that the right people have access to the data sets they need can be difficult if you don't have governance around it, or if that governance doesn't make sense for the size of your team anymore. Any transformations at the time that were more than something very basic were custom and completely manual. And the tools that they were using, again, they worked, but they just weren't scaling super well. Now, the process may not have been as manual as this file box here. It was digital files, but there was room to make it a lot less manual and make the team's lives easier. So Shane, in late 2019, approached the data analytics DevRel team, which is my team, for help creating a unified process that utilized GCP products. And this is where Emily comes in also. I'm the main point of contact for Composer and Airflow in my DevRel team. But when Shane first approached us, I was not in a position where I could devote a ton of time to making this implementation for him and the team. But I did have time to advise someone else to do it, especially if it were someone who were looking to learn Airflow for the first time. And that was Emily. Emily is a first-time Airflow user who not only had the time, but also had experience working with data like the data that we were going to use. It was a match made in heaven. So the goals that Shane helped us determine were that we wanted the process to be unified and repeatable. We wanted to utilize GCP products that were available to the public, that were designed to do this kind of data pipeline and data ingestion, to hopefully open source this process so that others could learn what we learned. And then my goal was to see what this process was like through the eyes of a first-time Airflow user. Beginners are so valuable. And even though I still don't consider myself to be an advanced Airflow user by any means, I'm not a beginner anymore. I know how to navigate the community and the docs. And it's helpful to see it through a beginner's eyes to see where you can help the community improve and be more welcoming so that it can continue to grow. So, what did we decide on for our solution? Before I dive in, I'll give a quick disclaimer. This is a work in progress. It's also a proof of concept. There are a lot of ways to walk through a flow like this, and there are probably parts that we missed and or could improve. We're still iterating on it with the public datasets team and fine-tuning it. So ideally, what we're hoping to get to, this unified process that utilizes those GCP products that we can hopefully open source, we'll have a user who wants to contribute to the public datasets program. They'll go to a public repo and they'll clone that and make a branch. This user who has a data set will bring some kind of configuration where they define where this data set is coming from, what kind of format it's in, any custom transformations if they're there, and they will upload that to a folder in the repo. They will run some kind of make or build job that will generate a DAG based on that configuration. They won't have to write that DAG at all, and possibly some kind of Terraform config to accompany that. This was a request from the team that we've not implemented yet, but I want to keep saying it to hold myself accountable. They will then create a pull request. And at this point, I just want to reiterate, the public datasets team has had nothing to do with steps 1 through 4. This is just someone who wants to come bring a data set to them. After they submit that PR, some pre-submit checks will run. They'll verify that the config file is shaped the way it's supposed to be, and any other checks we want to determine. And it's only at step 6 that will finally involve the public datasets team to do a review to make sure that this data set is what we want, that the pre-submits are passing. And then once they've done a back and forth, if they need to, they approve, they merge that PR, and they trigger some kind of deploy, maybe running a Terraform apply. And the result will be that this new DAG, or maybe it's a modified existing DAG, will be uploaded to the GCS bucket running in a Composer environment. And Composer/Airflow would run a new or a modified pipeline to start ingesting this data from an external source and then have it end up on BigQuery as part of the public datasets program. Where I'm going to focus in this proposed solution today is on the DAG itself. I don't know about you, but I certainly don't write DAGs perfectly the first time around, or ever. So instead of showing you the finished DAG, I thought it would be more interesting to walk you through Emily's and my DAG development process and how the DAG evolved as we worked on it. And I thought it was important to highlight how we worked on it instead of just showing you the DAG. Emily and I live and work on opposite sides of the country. So we were distributed before being on a distributed team was the thing this year. I wanted to highlight what worked well in the process because we really didn't feel too much friction being on opposite coasts. Our process was pretty simple, and it was probably because it was just 2 of us and only a proof of concept. So we didn't have to worry about some of the things you worry about when deploying a production app. But some things we did decide on. We had a shared repo. We used an internal repo, but any source control tool will do, where we both had admin and owner permissions, which with only 2 people, that's okay. But if you're doing this and you think this repo is something that could be with your team for a while to come, you may want to document somewhere that that was the choice that you made, because you later may want to change the governance away from make everyone an admin. We had a shared GCP project, just the 2 of us, and that was where our Composer environment and our storage and everything was. And again, Emily and I were both the owners. Again, I would not recommend doing that for a large team. Be smart and give your team the minimum amount they need to succeed. We also had a shared note document. And this is something I've also been doing with my interns this summer, and I highly recommend. We had a single shared Google Doc that was our meeting note the whole time we worked. So for every meeting, it was the same notes doc, and we just kept adding to it. We also used it when we were working separately from each other to kind of get our thoughts out for how we were debugging things. I know for me, when I'm working on a DAG, there's a lot of trial and error involved. And even though it can seem kind of tedious, I like to take the time to write down what variables I changed in between versions of the DAG so that I can remember where I left off. Not only was that useful for Emily, but it's useful for future me. It's also useful if you ever want to give a talk about something later, like now. And then we also had meetings. We both had pairing sessions as needed. Those were on demand, and it would usually be that Emily reached out to me to say that they wanted some help with the DAG and would meet for 30 to 60 minutes once or twice a week. And we also met with Shane and some folks from this project to make sure that we At the beginning, we were gathering the requirements, and as we continued to validate what we were building or to figure out if we needed to make adjustments. All right, so let's talk about this DAG. I'll refresh your memory. We're talking about public data sets. So in this experiment, we have a data set that we want to onboard. It's stored externally in an S3 bucket, and we need to get it into BigQuery. We know we want this DAG to be templated and automatable and able to be generated, but that's in the future. Right now, we just want it to work. This is why it's version 0.0. So the steps of this DAG so far, I'm going to use the little pointer. We have the S3 to cloud storage operator, where we are taking things from our S3 bucket and moving them into our cloud storage bucket. We then have a bash operator that makes a BigQuery data set that our data will eventually go into. We then use the cloud storage to BigQuery operator to move the Parquet files, the data set, into BigQuery. And then we have a temporary step where we were deleting our BigQuery data set. We added this because we were doing it over and over and over again and wanted to make sure that we were cleaning up after ourselves as we experimented. However, there was a problem with this. While we were cleaning the BigQuery data set up after ourselves, we were not cleaning up this GCS bucket that had a ton of stuff in it. And the reason why was because Emily, as a first-time Airflow user, couldn't find this operator that would allow you to delete objects from a GCS bucket. At first, I was kind of skeptical. I was like, okay, I know they've been moving around where the operators are. Maybe it's just in a weird spot. No, it turned out it wasn't there. At that time, the version of Airflow that was in our Composer environment didn't yet have the GCS delete objects operator. Luckily, though, there is a temporary solution. We were able to add that custom operator as a plugin. So you just import it like you would a regular operator. There are other solutions that have since come up. There are newer versions of Airflow now available in Composer. This is a few months ago that we had this problem, and we were later able to upgrade to a version of Composer that had that in there. And I also know that there has been talk about packaging operators separately. So if you know something about that, you should say it on the chat. So once we added this in, we had our same steps as before. We moved our data from S3 into cloud storage as a staging area. We made our BigQuery data set. We moved the data from GCS into BigQuery, and then we deleted the BigQuery data set to clean up and run the experiment again. And we deleted the bucket this time. Okay, so that was requirement one, was to get the thing to work. Like, that's great. We should absolutely celebrate that. But the whole thing was that we wanted it to be configurable and automatable. So how did we choose to do that? The first thing here is I want to highlight that the team gave some feedback that we could make the DAG assuming that the target data set and table in BigQuery had already been created. Emily removed that logic from the DAG itself and provided the team with a script that does that. So this is just a shell script that makes a BigQuery table and data set. I just showed the table part. And it also is under the assumption that the user provides data set schema in a JSON that the shell script then uses to build that data set and tables. I know that in the future, we may move this logic back into Composer or Airflow. This may just be a for now thing. So if you're looking at this and scratching your head, remember the disclaimer that this is a proof of concept that we are actively iterating. So the thing that Emily also added was a YAML configuration. So a user who wants to submit a data set, this would be step 2 of that like 6 emoji pipeline I showed you. The user would first make that JSON that I showed in the previous slide, and then they would fill in this YAML config where they would put info about their source. Here, this is the bucket, the S3 bucket where the data is located and what format the data is in. We have information about the destination. So this would be the name of the data set in the table that we created in BigQuery, the bucket in GCS where things are going to end up. Honestly, I don't remember what this lag is, but if I think of it, I will tell you during the Q&A. And then this section was really cool. This is column renames as a key value mapping. This is defining a transformation that can happen, defining it in the YAML instead of having to write it as part of the DAG. So now with the addition of this config, Emily did add some operators. The DAG has a Python operator that first verifies that everything we want defined in that YAML file is defined. And if it's not, it just totally stops. It also verifies that the data set and the table exist. Then we actually can begin this extract, transform, and load thing. We have just what we had before, only instead of the variables being defined here, they come from the template. We move the data from S3 to cloud storage. We move the Parquet files from cloud storage into first a temporary table. That's a new addition. And it's because we're then going to do a transform job where we'll move things to a final permanent BigQuery table from that temporary one. And in doing so, we apply the column mapping that was defined as part of the YAML. And then we can delete the bucket and delete the temporary table. At this point, we didn't need to delete the data set and table every time. We only deleted temporary resources, which is great. This is exactly what we wanted to do with this DAG. And I can't emphasize enough how exciting it was to see this coming from Emily, who is a first-time Airflow user. This is huge. So I could celebrate all day, but I also want to make sure that I share with you the lessons that we learned. One of the most important ones is to always double check your version of Airflow and or Composer. As I said, when we were worrying about that operator, we were using an old version of Airflow that just didn't have that operator we needed. And we were able to add it, but that process was not immediately obvious to a first-time Airflow user. And one of my goals was to see the process through the eyes of a first-time Airflow user. And I got exactly that. That is actionable feedback that I can work on in my role in Composer DevRel. Documentation is so important. I expected Emily to not be as independent as they were, partly because I needed a lot of handholding when I first started with Airflow. Now, a big part of that is because Emily is super smart, possibly smarter than I am. But another part of that is that between the time I started with Airflow and the time Emily started with Airflow, Airflow has had a lot of love given to its docs. Last summer, it was part of the Summer of Docs open source program. So if you're someone who's given love to the Airflow docs between November 2018 and now, thank you. Keep doing it. It's important. These contributions are amazing. Changelogs and release notes, along with documentation, are also extremely important. The changelog is how we figured out that that operator was straight up not there. It was very validating to realize we weren't doing something wrong. It just wasn't there yet. And it completely changed our approach from being like, oh, we can't figure this out to, oh, it's not there. Well, let's figure out how to make it there. And that's a lot more fun. And then it validated something that we already suspected, which is that transferring data between cloud providers is pretty easy with Airflow. So my call to action for all of you is to please keep contributing to Airflow, especially those non-code contributions like documentation. And if you are making a commit message along with some code contributions, make sure that commit message is as helpful as possible. If you're making DAGs and they're going to be for a broader team, or you think that they're going to carry on long after you leave your team, make it as automatable, configurable, and easy for someone new to Airflow to use. And then finally, the most important thing is to collaborate. Help someone new to Airflow learn Airflow. Encourage them to present about it. That was my whole plan, but we know that 2020 means that things never go according to plan. With that, though, I do want to say a huge thank you again to Emily for all of their hard work. I also want to shout out my two colleagues, Tim and Shane, who will join me during the Q&A. They gave Emily and I a lot of advice. They helped define the vision for this flow and even gave me some presentation content. A shout out to the Composer team and Rafael and to my DevRel colleagues and to all of you for watching. Thank you. Now, as I said, Tim and Shane will join me for some Q&A. Oh, and I got a note from Tim already as a thank you that lag is because we run a daily job, but the source data is about a month out of date. That was one of the values in the config that I didn't know about. So we subtracted that number of days to find the source file. Thank you, Tim.
Okay. Thanks, Leah. So Q&A time. Let's see. Do we have any questions out there?
Can take a peek at the Slack too.
Yeah, that's a good idea. No, that's not there. Okay. So no questions, it looks like?
Guess not.
You know, yeah, my experience has been that usually that just means you did such a fantastic job presenting it that there's no need for clarification.
Yeah, either that or everyone needs a lunch break. So if they come up with questions later, they should tag me in the channel. And if Tim or Shane have anything they want to add that they don't like how I phrased it, or they think that I missed something cool about it, you should do so.
Well, there was some interesting things about how we load onto BigQuery. So I guess I provided the BigQuery expertise to Emily, while Leah provided the Airflow expertise. We followed a pattern that's pretty common, which is we run a daily batch job, and we're using a time partitioned table to make your queries cheaper and easier to query. And the way we end up loading the data to that partition table, we don't load it directly. We actually load to a staging table, run some verifications there, and then actually use what's called a merge statement to basically atomically delete the partition and replace it with the data from the staging table. So I thought that was a pretty interesting pattern that we landed on.
Yeah, I guess the only thing I'll note is that we've acknowledged that one of the shortcomings of the Cloud Public Datasets program is it's difficult for external users to make a request right now for datasets that should be added. Outside of COVID-19 datasets, we don't really have a mechanism set up to do this, and so in addition to allowing us to kind of simplify our infrastructure, this is also going to help us kind of address that need as well. So I just appreciate the work that Tim and Leah have put in immensely. Yeah.
Oh, we do have, okay, so let's see. We do have some questions here, I think. So how many Cloud Composer instances that you set up for the process, question mark? Is there one for a playground? How many Cloud Composer instances that you set up? Let's see, yeah, that was the same question. Is there one for a playground?
Yeah. So Emily and I, for our experimentation process, just set up one environment. I would envision that by the time we have it in production, we'll probably have some kind of like staging and prod environment workflow. But we just had one for our stages now. And with the question, is there one for a playground? I don't 100% understand, but I'm going to guess. There is not like a free tier of Composer that you can play with. I would say if you want to experiment with Composer, you should experiment with Airflow and deploy it somewhere on GCP with your free credits, because Composer is geared towards enterprise users and is priced accordingly.
Okay. Next question, why didn't you use the transfer service to transfer the data from S3?
It's a good question. Do you remember, Tim? Did it have to do with the transformations that we wanted to do along the way and the human validation?
Yeah, that's right. So we wanted to run some validations, rename columns, all things that, yeah, we just wanted the flexibility that Airflow gives you compared to something that's not as programmable like the transfer service.
Yeah, the other thing to note here is like in this proof of concept, the data source was S3, but it might not be in the future. It might be an FTP server, it might be a GCS bucket, it might be an HTTPS server. So the long and short of it is that we needed the flexibility to get data from multiple sources, and we didn't want to confine ourselves to only pulling data from S3.
Yep.
Okay. Looks like last question here. Are there plans to add a visual DAG editor to Composer?
As far as I know, no. If that is different, I will let folks know in the comments, but pay attention to the release notes. I know that they have been working a lot on UI. There's like a Composer UI now that offers some more insight into the health of your environment. And some of the metrics of what's going on under the hood and brings them more visible in the context of Composer. But as far as I know, I don't know of a visual DAG editor coming as part of that UI, but if not, I'll let you know.